Okay, so I think we're recording. Basically, we're just going to go through some Python syntax stuff today, just so that you guys kind of get comfortable actually using the language. And is that too small? Should I make this bigger for you? Is that too big now? Maybe I can shrink that. Okay, how's that? Decent. All right, so the first thing that we got here are comments, and comments are nice because you guys can document your code a little bit. Just say what a function is doing or what a specific piece is doing, and you could do that by putting a pound in front of a line. If you're using VS Code, which I recommend, you could do command and the /. So that'll just put the that'll put the pound sign in front of the line for you. If you need to do a multi-line comment, then you can do it like this. You could do three apostrophes, or you can do 3 double quotes as well. It would do the same thing. So none of these things are going to be read by the interpreter. They'll just be skipped over. They're just for your own reading there. Okay. Oops, get up here. So let's just talk a little bit about the data types that are available in Python. You guys are probably familiar with Boolean values. So these are ones where we can either have a true or false. And in Python, as you can see, the syntax here, it's actually capitalized, whereas in JavaScript it is not. Numbers, we can have different types of numbers. Integers, which are whole numbers, we can have floating point numbers, and these are commonly known as decimal numbers. So if we had 5.3 or something like that, that would be floating point. Complex numbers, I don't think we're going to be doing anything with those. Strings, a text literal. Most pages in the web work with strings quite often. We've seen those a lot in JavaScript. You'll be seeing them a lot in Python as well. And then down here we've got these composite types, and these things are going to be made up of the other types that we saw before. So we can have a tuple, and this is a type of data that is immutable. So if we have a tuple, we can't change it after it's already been created, okay? And that is in contrast to a list. With a list, we can actually add items to it once it's been created. So otherwise, those two things will operate quite similarly. We can iterate through them in a very similar fashion. The third type that we see here in the composite type is just a dictionary. And if you guys, depending on how deep you got into JavaScript, in JavaScript that would be just an object literal. In Python it's a dictionary, and it's just a collection of key value pairs. Okay, and they look quite similar to what how you'll see them in JavaScript as well, because they're opened up with those curly braces. Now the next thing that's super important in Python is indentation and line endings. And with Python, we actually have to make sure that things are indented if we want it to be inside a block of code. So here, as you can see, we've got this function. That's what the def keyword means. It means that we're starting a function definition here. And then inside there, notice how everything is indented at least 2 spaces. And depending on your text editor, you can change that to 4 spaces or whatever you want. But they have to be indented 2 spaces over, otherwise it's not going to be interpreted to be inside that particular function or inside that block of code. So here inside, when we ask if name, notice how we indent even further over to actually print something. Okay, so that tells us we're inside that block of code, and to introduce some block of code, we're going to put a colon. Okay, so if this condition is met, put the colon there, and then you move down to the next line and indent a little bit further than where you were before. So just to demonstrate this, I've got a little command prompt open up here, and oops, let me see if I can make this bigger too. Okay. So if I want to get out of this, I can just go exit. But you can actually open up, once you have Python installed on your computer, and if you're on Mac, you probably already do have it, you can open up a shell to interact with Python directly by just typing in Python. I'm going to do Python 3 because Macs usually have Python 2 on them as well. And now we're actually inside the Python shell, and we could do some different things. So for instance, if I wanted to say if true, notice what happens. Let's just say we'll go print this was true. Whoops, I forgot my. Notice how we got an indentation error. Can you guys see that okay? Yeah, so this is what Python will do if you don't actually indent inside of some kind of an if condition. So let's change that there. We'll go if true. And then when I return, I'll just do some spaces. 1, 2, 3, 4. Print this was true. And then we actually have to return again when we're inside the shell because it doesn't know if I'm done with that inner block. So that's how we do it with indentation. Little bit different than JavaScript because JavaScript doesn't care about indentation. In JavaScript, we actually need a semicolon, or it's not required, but generally you'd see semicolons at the end of lines. In Python, we don't need that at all. No semicolon needed. All right, let's take a look at what else we have here. We've got strings. We talked about that. This is a pretty important data type here. So you can print a string. You can assign a variable to a string. So in Python, when we're assigning variables, we don't need a var keyword or a let or a const like we do in JavaScript. You just simply say that thing equals something. All right? You can see it's been assigned to the variable name here.
Morty, I have a question.
Yes.
What if we wanted to like create a variable but like we don't know the value?
Mm-hmm.
Do we just write the name of that variable?
You could. I don't know that you'd be able to do it with no. Yeah, you can just set it. Well, let's say x. Yeah, that's not going to work. You're going to have to set it equal to something. I mean, you could set it equal to an empty string and then change it later on if you want. Yeah, but you wouldn't just like say variable name and just leave that on a line by itself. It's going to need some kind of assignment to it. All right. So that's kind of a difference between JavaScript and Python. In JavaScript, what you were talking about is we're just simply declaring a variable. We haven't really assigned it to any value, and you can obviously assign it to a value later on. But in Python, you're going to need to get right to it and actually assign it to something. Okay? And then these are some different ways that you can actually print out a string that is concatenated. So we're taking multiple different strings and putting them together. We could do something like this where we do a comma. And let's try that real quick. So if I say print, oops, I'm going to reassign x equals something. And then we'll say print x, comma, something else. Okay, so there we go. So that's one way that we can sort of concatenate two strings together when we're printing them, is we just with a comma. The other way that we could do it is we could put a plus in there to add them together. So I can say print x plus something new. All right. And you'll notice in the first case we actually got a space in there, which was created by that comma. In the second case, we didn't get a space. It was literally just crunching them together as they were. All right. This talks a little bit about interpolation. We can actually put values inside of a string, or placeholders. You see these little curly braces here? And then what the .format method is going to do is it's going to fill in these placeholders with the values that you supply to it. Okay? So if I give it a first name argument, it will then plug that in. So first name was assigned to Zen, right there. And then Zen is going to appear right there in the string. Of course, last name was assigned coder, and that's going to be plugged in right there. Okay? And that's like what you guys were probably familiar with JavaScript. We do console.log just to print something out. Okay. Let's see what else we got. Built-in string methods. We've got some kind of like what we saw this morning. Dot to uppercase in JavaScript. Here we've got dot upper. And as you can see, that would actually turn everything into uppercase. So if I say print hello and then upper, that will capitalize every letter in the string. All right, and then this is just kind of a list of some different methods on strings that you can use. And as it mentions down here, don't worry about memorizing every single one of these, because a lot of times you're not going to need something all the time. So it's much easier to just look it up rather than burdening your mind with all this extra information. Okay. Let's see what we got next here. Lists. This is a pretty important type, an important composite type like we talked about. So just like in JavaScript where we've got arrays, in Python we have these things called lists, and it mentions here they're known as arrays in other languages. And you can very easily create a list by just using the square brackets here. So if I say ninjas, I'm both declaring and assigning this variable here, and then I've just created a list that has some different strings in it. And you can also have a list, as you can see here, with different data types in it. So we've got a string, and then we have another list nested inside of that, which has a bunch of strings in it. And then we have a number tacked on to the end of the outer list. Okay? And you can create an empty list by just going like that. It has nothing in it. If we want to, let's see, if we want to access values, it's going to be exactly the same as it is in JavaScript. So this will be very familiar to you. You would just use the index number that you're interested in. And as you can see, drawer at 1 is going to point to this item right here, envelopes. And if we were printing it, it would actually print envelopes. And then the other thing that we're going to do on occasion is we might manipulate lists, so we might want to add another item to them. And the way that we can do that is with the append method. So you can do .append, and then just as the argument that you're going to provide it, that will be tacked on to the end of the list that you have. All right. Here's another pretty cool thing that Python has, which is if we don't provide just a single index, if we do something with a colon, what it's going to do is it's going to take a slice of that list. And in this case, if we just do a colon with no numbers on either side, it's going to basically take a slice of the entire list. So as you can see, that would be the entire list. If I put a number in front, it means that this is the index that I want to start from. So rather than starting from 0, we're actually starting from 4. And that gives us 4, 2, 5, -3. The other thing you can do is leave the front blank, which means that we're going to start from the beginning, wherever the beginning is. And then you can specify an endpoint. The key thing to remember here is that this is non-inclusive. So if it is index of 4 will not appear in your, probably in your new list. But if you were just printing something, it wouldn't show the index of 4.
It's a limit.
It's a good way of thinking of it, yeah. And in JavaScript, there's the .slice method, which is largely similar. But one thing that this this has that the dot slice in JavaScript doesn't have is that you can also specify a step on it as well. So rather than just doing, I don't know that that's even mentioned here, but if I wanted, I'll just create like a quick list. So we'll say list equals 3, 4, 5. And then if I wanted to print, say, character 3 and 5, I could probably do print list, and then we'll specify some things out. So we'll start from the first, which means it'll just be blank, and then we'll go all the way to the end. And then I can also specify a third item inside that, which means how many steps I want to move forward. So if I do it like this, notice how I skipped over 4. And the reason why is because the number of steps can just determine how far I want to move with each iteration. So I could also do, if I did 3, I should just get the number 3 because obviously we're doing step 3, so we actually would go off the end of the list. Right? Some other built-ins on lists is that you can get the length of a list by just saying len like this. So if I say print len list, there are 3 items in my list. Here are some other methods here. You can enumerate used in a for loop to return 2 item tuple for each item in the list, indicating the index followed by the value at that index. So let's try that real quick. So if I want to go print enumerate, whoops. List. Well, that didn't really seem to do anything. I doubt you'll end up using enumerate, but if you do, I'd be surprised. Anyway, but there's some other methods here like map, min, sorted. Like I said, dot append is probably something that you'll use fairly regularly. Pop means we can remove a value at a given index. So let's try that real quick. We'll do list.pop index of 1. And then that gave us back the actual value that was at that index. So now if I print the list, it should be theoretically be missing that value. Yeah, so now we only have 3 and 5 in there. All right. List.index value returns the index position in a list for the given parameter. So if I'm looking for, say, the number 5, I could drop in a 5 here, and it should give me an index of 1. There we go. So these are just some of the things that we can do to manipulate or extract information. And then there's a little link here, too, where you can learn more about other built-in functions. I'm trying to think why you would want that, though. I don't know that it would. We can test it real quick, but I don't think that would work. So if I said object equals, we'll just say some prop, some val. Okay, so if we go object print object dot list, and then I pop in some value, I can't imagine this would actually work because this is not available on objects. Yeah, so a dictionary does not have a method that we can list with. Okay.
I have a question on that last part. If you have a list with the same value at multiple indexes, or just return a list of all the indexes?
Should give you just the first, if I remember correctly. Let's see. So if we go list dot append, let's just add another 5 to it, and then we'll say list dot index of 5. Yeah, it's just going to give you the first. Yeah. All right. So the next thing we're gonna touch on briefly is just these conditional expressions. So as you know, these things are quite important. Our old if, else if. So in Python, our else if would actually be elif. Kind of funky. And then our else, of course, that you guys are familiar with already. And again, we're always going to introduce these blocks when we have some block of code that we want to run inside of these. Introduce them with a colon, rather than in JavaScript you'd be doing curly braces. Okay. And then, of course, the indentation is very important. So as you can see, when we introduce these conditions, make sure that you indent. Of course, if you have a comment in there, I don't think that would cause any problems for the interpreter. If you had a comment that was flush up against the left, I don't think it's going to mind. Might look weird to your eyes, though. So here's an example here. If there is construction, use detour. This is just an example of sort of what we like to call pseudocode, and that's just sort of how we're thinking about the code rather than how exactly it needs to look in terms of syntax. Here's another example here. So if we say age is 15, if age is greater than or equal to 18, print legal age. I'll just grab this, drop it in. You guys can see that at work. Whoa. Unexpected indentation. It doesn't like my indentation. All right, maybe we won't do that. Age equals 15. And then we'll say if age is greater than or equal to 18, we'll print legal age. Obviously, this is not going to print because it was not true. If I go else, print you are so young. Whoops. There we go. So we got our else there. Okay. And then it just mentions in here, it's kind of weird that we have this elif, but that's what that means. It means else if this other thing is true. Okay. Here are the comparisons that we have. So the double equals checks if the two values are equal or not. 1 is not equal to 2, so that's going to return false. 1 is equal to 1, so that would return true. You guys can look through this a little bit. And then another kind of contrast here between this and JavaScript is that rather than using the double ampersand to indicate that we want two things to be, or multiple things to be true, we're going to use the word and. And we'll use or and not as well. This reverses the true-false value of the operand, so not true is false. Makes sense, right? Okay, and then so there's just a little note down here. The exclamation point equals can also be written as this, but this is an obsolete usage, so don't do that. The like opening and closing carets, so you can just basically ignore that. All right, stick with the old not equals or not. You could either use this, the not equals, or you could say not to indicate that. All right. Loops, the last thing we're going to touch on. Loops are pretty important, as you guys know. Let's just talk about this real quick. So if we're trying to do a for loop, there are some different ways that we can do it in Python. We can specify a range of numbers like we have here. So for loop or for count in range. Let's just do that. For count in range, and I'll say, bless you, 0 to 10. So again, this is the second number, just like we saw when we were slicing, is going to be excluded. Okay, so if I specify 10 as the second number, it should be left off when I print things. So I'm going to go colon and then space out on that, and we'll just print whatever count was. Okay, so we went all the way from 0 to 9. If I want to leave off the first number, I can do that as well. So I can go for count in range, and I can just say 10, and it will still start at 0 for me. So same thing. And so here's just the general syntax of how this works. We're going to do for counter in sequence or range, and then you'll put your colon there and then introduce whatever block of code you want to run. All right, so here's an example of looping through a list. If we had this list, well, let's do our own list just for posterity. So we'll say, I'm just going to reassign our old list, and we'll say this, that, the other. Okay, so one way that we can loop through this list is we can say for item in list, I can just print the item. Okay, that's one way to loop through a list. The other thing I can do is I can actually loop through the indexes, or the indices of the list. If I do for I in range, and then my range is just going to be the length of the list itself. So I could say len list, and then down here I can of course call on individual items in my list. So I can say print list at I, like that. Same thing. Okay, so only this time we're referencing it by index as opposed to just using the item itself. All right, then there are while loops. See an example here. We could say while count is less than 5, print looping, and then we'll increment count. So the key thing about while loops, as you may have come across in JavaScript, is we have to make sure that the condition is going to become false at some point. Otherwise, that while loop will never stop running. And you're going to have trouble if the while loop never stops running. Okay, so the basic syntax is just this. You'd say while, and then the condition. So we'll do this real quick. We'll just say count equals 0. And then we'll say while count is less than 5. Whoops, I don't even need these. While count is less than 5, let's print count, and then let's increment it as well. Oh, I can't increment it that way. Let's try that again. Count equals 0, and then while count is less than 5, let's print it, and then we're going to go count plus equals 1. That means that we're adding 1 to it every time. And there we go. So that's how to use a while loop. And really a for loop is essentially just a specialized case of a while loop. That's all it is. Because in a for loop, we're doing something while a condition is met. And then here's a little diagram about loop control. You guys can kind of read over that. In the meantime, pass. Okay. So this is kind of like when we have to have a statement and we just don't don't have anything to put in it. So this is an empty class. You can put the word pass in there just as a placeholder, because if you leave that class empty, you'll run into an error. For instance, in here, if I just say class some class, see how I'm having trouble here because it's saying you didn't indent after you declared a class. All right, so if I change it and just put pass in there, it won't cause any trouble with the interpreter, right? Certain conditions that we give for every loop that we have. While you can actually incorporate else inside of a while loop, which is a little bit different. Okay, so when that condition is not met, so in other words, when y is not greater than 0, we will finally print this thing. So essentially, if you think about it, that's just going to run at the very end once the thing has been turned false. All right. You know, the other thing you could do is just print this outside of the while loop entirely too, right? You could finish up the while loop and then just print it, and that's probably what I would recommend. Let's see what else we got. Because of the break, then there are breaks that you can add in as well. So that's something that you probably saw in JavaScript. If you want to break out of some type of a for or a while loop, you can use the break keyword, and that will actually break out of that part of the iteration.
When it breaks out, will it evaluate the else, or will it break out entirely?
Well, we won't. So let's see. If we get to the break part, it should break out entirely. Saying because of the break, the above code will output the following. Yeah, so see how we didn't actually get the final else statement?
Yeah.
Yeah, so it's going to be a complete break. It won't run the else on that. Trying to see if dictionaries are, oh yeah, dictionaries are here. We definitely want to look at those real quick. So functions, we saw those briefly. We just introduced those with a def. So the def keyword says that we're declaring a function here. You'd have the name of the function and then the parameters or the arguments that function is going to take in. And then, of course, you can invoke it here. So we'll just do this. Let's just create a quick function. We'll say def print name that takes in some name. And then we'll just print that name. So down here, if I want to invoke print name against my name, it should print that for us. So there we go. So that's how we invoke a function, actually the same exact way that we do it in JavaScript. So that's kind of nice. No differences there. This is all about the syntax. Nothing too exciting there. Okay. Next thing I think we'll look at real briefly is just dictionaries. I think I'm going to skip over tuples because they're very much like lists. But again, tuples cannot be changed once you create them. That's the big key distinction there. Whereas a list, we can append, we can pop, we can change the list. All right. A dictionary is another mutable set type that can store any number of Python objects, including other set types. All right, so to create one, all we need to do is just set up something like this, like I did earlier with that dictionary. And then you can call on specific attributes of that dictionary just using the attribute name on that. So if we want, well, let's add some values real quickly. So if we say object equals some empty object, and then I can say if I want object at this to equal the string that, then I can actually print that specific attribute, of course, by calling on it this. All right, so that's how we can get individual properties or attributes of our dictionary, from our dictionary. And they talk about accessing down here. There are some other ways that we can iterate through a dictionary. We can use iter keys, which will print all the keys that that are in that particular dictionary. We can print all the values by using iter values method. Okay. Or we can do this is kind of a fancy little thing. We'll test this real quick. We can print both the key, or we can do something with both the key and the value if we do the iter items method here. So our object has one thing in it. Let's just do object at some other property. Some other equals some other value. Okay, now what I want to do is actually iterate through the properties that are, or attributes that are in that dictionary. And we'll say for item in object dot iter. Whoops. We're going to say for key val, and you can name these anything you like. You could call them key and value, doesn't matter. It's up to you. In object dot iter items, and then I'll print the key and the value. Oh, sorry, iter items is not. The platform says iter items, but I believe you can do it with dot items like this. Key val. Okay.
Can you raise up the window, the code window? It's hard to see the bottom of it. It's like,
Oh, just bring it up. Yeah, totally. Sorry about that. Let me make it a little bigger too.
How do you make them like inline to print the key value pair inline? Because right now it just starts a new line when it goes to the next key value pair.
you just do like key plus space with quotations.
Oh yeah, I see what you're saying. Yeah, one thing you could do, I guess, is you could create a new string and then just keep adding to it like that if you wanted. Because otherwise it looks like print is going to start a new line each time around. So yeah, if you wanted it to just be one long string, probably that's the easiest way, is to just create the string as you go, keep adding to it with each new key value pair. And then you could print it out at the end, of course, if that's what you wanted to do with it. Here are some built-in methods on for dictionaries. So len is actually shared by list. We could do the same thing here. We could say print len object, and it has two key value pairs in it. All right. Here's some other methods here. Nested dictionaries. You can also nest them. Kind of nice. Anyway, it's kind of like a high-level overview. I don't want to like keep droning on all this stuff, but that's the main stuff. Is you're going to be probably adding properties to dictionaries. You'll be referencing specific properties to get values out. Maybe you'll iterate through them like we just did there. That might come in handy here and there. But that's pretty much it. You guys have any questions about what we went over today? I know it's a lot of stuff and it's very fast, but that's kind of how it is.
Just earlier when you were talking about those lists, I just wanted to know about those two colons and then like I'm lost.
Yeah, that's kind of an interesting looking syntax, right? So let's say if I go list, I know I still had a list, so if I just go list with an empty colon here, that would actually return my entire list back because I'm not specifying a start or an end point. Or if I want to specify a start point, I can say list starting from 1 and then by not specifying an endpoint, it would go all the way to the end. Okay, so that time we start from an index of 1, just go to the end of the list.
It's when it's 1, that's an index of 1. It's not like.
That's not the value, yeah, it's the index. Or if I wanted, the other thing that I was talking about here is that if I want to specify some sort of step so that I'll skip over certain ones, I can specify after the second colon 2, and that means that I'll jump over the middle item in the list. You see how that was skipped that time around?
Okay, yeah, I think that's when I was lost.
It's kind of like an iteration.
Yeah, so it takes these 3 different things and they're all optional. So you can specify a start point, an end point, and then some step for how far you want it to move each time around. Yeah.
So in the list, colon 2, is that 2 is a value or 2 is an index?
2 is the step. So after the second colon, you can insert the step, which is how far do you want it to move on each iteration.
Like, if you didn't have it on there, it's at least what I was thinking of it was like icons plus just going up by 1. It's the default, but at that time you set it to it's going to go up by unit skip 2.
So let's just add another value to it. Some final value. Okay, and then we'll do list, but this time I'll specify a step of 3, which means we're gonna skip over 3 items. Or I'm sorry, 2 items. So the step would be 3, which means that we went from an index of 0 all the way up to the index of 3. So we added 3 to the index that we started on to end up with that. I know the syntax looks a little strange, but the colons are just, again, in front of the first colon, that means the start point that we want. And then after the first colon is an optional endpoint. And then after the second colon is another optional argument, which is how far we want it to run.
Oh, so the colon is basically the thing that you want to subdue. Is that how?
The colon is sort of a delimiter. It's just delimiting these different indexes. Well, in the last case, it's not an index, but it's delimiting these different. I would almost call them arguments.
Kind of like that. Make them invisible. Like, depending on how many are you. If there's like 3, then the 3 colons, then what would happen?
I don't know. Probably nothing. Yeah, syntax error. So really, the only amount of colons you can do is 2, and you would only specify 2 colons if you want to put that optional step argument in there. If I'm not going to use the step, I would just use the single colon. So I could do something like starting from the beginning and going, well, yeah, so this is only going to give me the very first item because I specified an end index of 1, but that individual item is going to be excluded with the way that this works. So we just get the very first item. Does that make sense? Or is there still some confusion there? It'll probably make more sense with some usage of it. But yeah, think of those colons as just delimiters. They're sort of separating the arguments. Is all. Yes?
Could you show us what it would look like if you wanted to have a start point and end point and a step?
Sure. So let's say, oops, list. And we'll say our start point will be 1. End point would be 3. Or actually, let's say endpoint is 4, and then our step is going to be 2. So of course, the index of 1 is the item that, right? And then the final value is the index of 3, which we added later on. And then the 4 just means we won't include index of 4, and actually there's nothing at the index of 4, But you can see that that 2 just means that we stepped over the next value, which was the other up here.
So the 2 is the index of.
No. 2 is not an index. 2 just means how far do we want the thing to move on each iteration.
Oh,
2
like,
is a number you add to your current index.
Correct.
like
So
that.
that
So
you
it's
get your
basically
new-
like I plus 1 is this basically I plus 2. So every time it's going on, it's okay.
Exactly. Yeah. So the first 2 numbers are actual indices. The third number is the step, or how far we want to iterate each time.
So you print the list by doing list and then just doing a colon. So you just do like print list.
Yeah. So if we actually print this, then we should get pretty much the same thing. If we go print list 1 4 2.
Oh, no, I meant just like if you want to print the whole list. Like,
Oh, you mean print them individually?
No,
no, I mean just like in general, like if you want to print a list, whatever list you have, you just want to print all the values. Could you just write print list, or is the only way you can do it list?
Is it
Yeah.
different-
Yeah. You can print absolutely. You can print the list by itself. Yeah.
Okay.
No
What is
problem.
the difference between that and then doing list bracket 1 or list bracket colon? You were saying that if you do list bracket colon, it's returning the list.
Yeah, exactly. So it's giving you back what's called a slice of the list, which means it's essentially like taking all the values that were in that list and giving you back. Like I can create a new, I don't know, let's say some new list equals list. So this should give me a slice of the original list. Now let's add an item to the list 4. And then let's print the original list. Okay, so what happened here is that I took a slice of the original list and I created a brand new list out of it you'll see here when I said some new list equals that slice, which means they're not now referencing the same exact list. They're now 2 distinct entities. So if I make a change to the original one, or if I make a change to the new one, they're not going to affect the other one. And that's kind of why that's useful, is that sometimes you don't want to affect the original list that you have. You just want to create sort of like a new copy of it and then make changes to that.
So if you just did some new list equals list without the bracket, and then you appended 4 to some new list, it would also append to list?
Correct, because at that point they're now, so let's do that. So let's say third list equals list, and then if I go third list dot append 4, and then I print list, notice how they're actually both pointing to the same exact thing. So if I add to one, it's going to add to the other because they're referencing the exact same list. Whereas when we slice it, we're creating sort of a new copy of it, but it won't affect the original copy.
I have a question kind of related to that. If you were dealing with another variable type, like if you wanted to take a new variable and set it equal to an existing variable without modifying that variable, is there like different methods for each one, or are you always modifying the original variable when you change the?
You mean like if it's a string or something
Yeah,
like that?
if it was a string or an integer or whatever, will you always change the first variable when you modify the second one?
Let's try. So let's say some string, some val. I don't believe so, but just to check, and then we'll say some other string equals some string. Okay, so now if I say some other string equals new val, now you want to know, does some string equal new val now?
Yes.
No, I don't believe so. So let's check. So print some string. Still what it was originally. Yeah. So when we're talking about strings or numbers, those aren't going to have those types of issues where, you know, like we can overwrite another variable or something. But things like lists and dictionaries would essentially have that sort of issue where if you have two variables pointed towards the exact same reference, changing one will affect the other, and vice versa.
I have one more kind of unrelated question. Earlier you changed an iterator from plus to plus equal 1.
Mm-hmm.
Does plus and minus not work in Python?
Correct. And I sort of forgot that. So yeah, I mean, little things like that, you'll notice differences between the languages. Yeah. All right, we good? You guys ready to get some Python going? All right. Have at it.